Okay, we're going to begin Module 4 today, which is a fun unit on describing and analyzing data. And we're going to begin today with something I think you already have on your hard drive. You've at least been exposed to it in the past. And here we're going to relearn it at a higher level. And that is I can calculate and interpret the mean, median, mode, and range of a data set. So in this unit, our data sets are all going to be numerical. And numerical data set is a collection of numeric data where the numbers typically represent a specific quantity. The numbers within the data set are called elements. So here in example 1, we have test scores of students. So there's the scores. We have 7 different numbers, so we say we have 7 elements. In example 2, we have dolphins eating fish. I'm not sure if this is per meal time or if this is how many fish they eat in a day. I'm not sure about that, but it's fish eaten per dolphin. And so we have 8 different numbers in there. So there must be 8 dolphins that they're tracking how many fish they eat. And so in this example 2, we say there are 8 elements. The mean is the average value of a data set. And so a lot of times people just call it average, but the official academic vocabulary is mean. All right, so how do we calculate the mean? Well, we add up all the values in the data set, and then we divide by the sum or the total number of elements within the data set. So here in example 1, we said there's 7 elements, right? There's 7 numbers in the data set. So first step is you have to carefully add up these numbers. You may use a calculator, so just make sure you key them in correctly. And you get 623. But that's not our mean. That's not our average. That's the sum of all those values. So step 2 is we take that number and we divide by the number of elements, or the number of numbers that are in that data set. So in this case, it's 7. So to find the mean, it's 623 divided by 7. So in this example, we get 89 is our mean. So we'd say that the mean or average test score for students is 89. For example 2, we're going to do the same thing. So this time we have 8 elements. So we're going to add those numbers up. And this time the sum is 103. And then step 2 is we're going to take the 103 and we are going to divide it by 8. So we get our mean value is 12.875. It will not always come out as a pretty number. So now the mean or average number of fish eaten per dolphin is 12.875. Since we're talking about number of fish eaten by a dolphin, most likely you would round that to the nearest whole fish. So we'd say approximately 13 fish per dolphin. Here's a data set of IM1 formative quiz scores. What I would like you to tell me first is how many elements are in this data set. And the data set includes these 4 rows. These first 3 rows, I will tell you there's 10 numbers in each one of those rows, plus this 4th row is obviously not 10 numbers. So how many elements are in the data set? I hope you came up with 34. There's 34 scores here represented, which means there's 34 elements, and those are students in this example, right? There's 34 students in the class. Now, I'd like you to carefully determine the mean. And why I say carefully is, golly gee whiz, we have a lot of numbers here. So you need to be careful. Use your calculator, but make sure you're keying in the right number. What is to figure out the mean for this data set? So to represent the mean, I'm using what's called X bar. I have X to the bar above it. That's going to represent the mean. And so that equals 2,132, which was the sum of the 34 numbers here. And then I divide by the 34. So our mean is 62.7. 62.7 is our average test score in this quiz, and I am 1. It's a little low. Okay. Now I wonder if those zeros kind of impacted our mean, if you will. There's 5 students who didn't take the quiz, so we had to put them down as a 0, but they didn't even take the quiz yet. So let's take those students out of our data set. So here's our new data set. So we had 34 elements before. We removed the 5 students that did not take the quiz. So we take out the 5 zeros. Here's our new data set. How many elements are in this data set? I hope you came up with 29. There was 34 before. So then all you do is subtract out the 5 zeros we took away. So that got you down to 29. Or by all means, you could have counted the numbers again up here and got 29 as well. Now I want you to find the mean for the data set, but let's save you some time. All we removed from the last one that we just did is the 5 zeros. So 5 zeros, and you add those up, it's still 0. So our total is still going to be the same number, right? So that number was 2,132. So there's your hint. Can you come up with the mean now for the data set? So I hope you see that it did make a difference when we removed the students from our data set that did not take the quiz yet. So we have the mean is 2132 divided by 29. So our mean is 73.5. So it did make a big difference by removing those zeros from our data set in this example. So the mean is one way we measure the center of a data set. Another way of measuring center is median. So the median is the middle data value within the data set that has been written in ascending or descending order. So ascending means it's increasing from smallest number to the largest. Descending would mean it's going from the largest to the smallest number. So example 1, we have our test scores here. These were not written in any type of order. So our first step is to rewrite the data set in ascending or descending order. I'm going to use ascending. So we write it as 64, 89, 89, 92, 94, 95, and 100. Okay? Step 2 is we simply cross off a number from each side, from the highest number and the lowest number until we get to the middle. And in this example, we have an odd number of elements. So as we go through this process, we'll get to just a number in the middle. And you can already see it because I have it color-coded already, but let's go through the process. So smallest number, 64, biggest number, 100. Let's take those out. Next smallest number, 89. Next largest number, 95. Next smallest number, 89. Next largest number, 94. Since we have an odd number in our data set, we come out with the number in the middle. That, a lot of times we'll circle it, that is our median. So that means half the numbers are greater than 92. The other half of the numbers in the data set are less than 92. So the median test score is 92. Oh, it's a little bit different than our mean. Our mean was 89, and our median is 92. And we'll be talking about later in this unit about what causes those differences as we measure the center of the data. All right, let's find the median of our second example with the dolphins and how many fish they eat. So again, our original data was not given in any particular order, so we're going to rewrite it. I like ascending, so I went from smallest to largest. All right, now we're going to go through our process, and we're going to cross off numbers from each side. But this time, I want you to notice we have even number. So we're going to cross off until we have just 2 numbers remaining, okay? So smallest number is 8, largest number is 20. Next smallest is 10, next largest is 18. Next smallest is 10, next largest is 15. Oh, we're left with these 2 numbers, 10 and 12, okay? So now we have an added step in this situation when we have an even number of elements. And our next step is we need to find the mean of those 2 middle numbers, and that will be our median for the data set. So all we did is go, 10 plus 12 divided by 2. So we got 22 divided by 2, which is 11. So the median number of fish eaten per dolphin is 11 fish. So again, that's a little bit different than we had when we found the mean, right? The mean was like 12.875, where we said about 13 fish. So you see that our median number is a little bit different than our mean. As we go through this unit, there's going to be certain types of data where it makes more sense to use the mean for the measure of center, and other times it makes more sense to use the median as the measure for the center of the data set. All right, here's our first data set. I have it written in ascending order for you, so it's nice and pretty. I want you to figure out what is the median of the data set. And this is the first one we did where we include the 5 students that did not take the quiz yet. They're zeros. We include that in our data set. So what is the median? So as I went through the process here, I got down to 70 and 74 because we had an even number of elements. And so then we take the average of 70 and 74. So we add them up, divide by 2, and we get our median is 72. Oh, again, this is a big difference from the mean we did the first time with this data set. It was in the low 60s, right? So this was a lot higher again, and we're going to be talking about why the measure of center of the data set can be pretty different from the median to the mean, what causes that, and which number makes most sense for us to use depending on the situation. All right, let's find the data set here. We removed the 5 zeros, so we have our data set in ascending order for you, all nice and ready to go. There's 29 elements, so careful. This time it's an odd one. All right, so can you find the median of this data set? Interesting, when we take out those 5 zeros from the data set, our median now is 77. So that went up just like last time. The average went up, right? When we did the mean, it went from the low 60s to the low 70s. Here, the median went up from 72 to 77 when we removed those zeros from the data set. Mode is the element within the data set that occurs the most often. That's all the mode is. It just which number occurs the most often. But here's the thing. Sometimes data sets have more than one mode, right? So if you have a data set, let's say you have 100 values, 100 elements, right? And there's 3 different numbers that occur 6 times each. Well, then you have 3 different modes. So that's common. So a data set can have more than one mode. So here's our example number 1. It says rewrite the example set ascending to descending order. Just helps to see the repeats that you have in the data set when you have it written this way. Otherwise, it's harder to pick out if your eyes are going all over the place to try to find out, well, how many 95s are there? How many 64s are there? When you have it written this way, you can see it. And here it's nice and clear as day. You see how we have the 289s. So the 289s, that's our second step really, is to identify which one occurs the most. In this example, it's only one number repeats twice. So the mode for this data set is 89. For our dolphins eating fish problem, this one, when you rewrite it in ascending order, it sticks out like a sore thumb, right? You have 10, 10, 10, 3 times. We have 3 10s. So that is our mode. So the mode for this data set is 10 fish eaten per dolphin. All right, let's look at our first data example. This is the one where we have the IM1 quiz scores, including the 5 students that didn't take the test. So there's 34 elements. Everything's listed in ascending order, so you can see the numbers that are grouped together. What is the mode for this problem? The mode for this data set is 60. Now, I bet some of you accidentally said 0, 60, and 80, just because you may have missed the way this was lined up, how the 60 was up here as well. You might have saw 5 60s and 5 zeros and 5 80s. If that's the case, you would have had 3 values for the mode. It would have been 0, 60, and 80. But in this case, there's actually 6 60s in the data set, so that is our mode. Now, our next data set we know is all the same numbers except we remove the 5 zeros. Is that going to impact our mode? In other words, is our mode going to be the same value this time as it was for our last data set? Our mode in this example is also 60. We have 6 60s. We don't have zeros this time, but we had the 80s, but there's only 5 80s in there. So the mode is clearly 60. Let's close out with range. Range is the positive difference between the largest and smallest numerical value within the data set. So that's all it is. It's just you take the largest number and the smallest number, you subtract the smallest from the largest. That number is the range of the data. So in our example, we have it from smallest to largest. So we can clearly see that 64 is our smallest value, 100 is our largest. So we go 100 minus 64 and we get the 36. So the range for this data set is 36 points for test score. So that means students' test scores, that gives you what's the variance in the scores. They go from 100 all the way down to 64. That's the difference of 36 different points possible on the test. Example 2, our smallest number is 8. Our largest number is 20. So the smallest meal is 8 fish for the tiny dolphin, and the big dolphin had 20 fish. All right, so step 2, we're going to subtract the smallest from the largest. So we go 20 minus 8, which gives us 12. So the range for this data set is 12 fish in per dolphin. So that's a pretty big range, pretty big difference for how many fish each dolphin is eating. This should be some quick math for you. What's the range of this data set? I hope you got 100. You want 100 minus 0 is 100. That's the range. Our next data set, this should take you a little bit longer, but not much. What's the range for this data set? I hope you got 77 for the range. We went 100 minus 23. That's how we got 77. So when we took out the zeros from our original data set, it made our range a little bit smaller, but that would be still a little too big for my liking if I'm looking at test scores for a class. Anyway, that's it for today. Hope you had a good lesson. Let me know how things went.